Now we are starting with December 2018 question paper, and this is the third question. Says that in an RLC parallel circuit. Okay, so what we will do is we will draw that parallel circuit. So here we have R, L and C. Okay, it has been given AC input. Now here values are not specified. Fine. Now here it is 15 amperes. This is R, L and C. Here it is how much? No. The first current is 20 amperes. Here it is 15 amperes. And the third current is 40 amperes. Yes. So let us quickly write here. Correct? So IR becomes 20 amperes. IL becomes 15 amperes. And IC becomes 40 amperes. So what is the current taken by the supply? From the supply, and draw the phasor diagram. Now if we talk about the current through inductor, we know that if this is V, then here we have IR, isn't it? Because current through a resistor is in phase with the voltage. But if you talk about the inductor, it lags behind, right? So here we have IL. If you talk about the capacitor current, it leads behind by leads, by 90 degree. So this is 90 degree, this is 90 degree. So this is IC. So what is the resultant current on y-axis? The resultant current will be, suppose this is V and this is somewhere here is IR. Then the resultant current will be either IL minus IC or it will be IC minus IL. Now whether it will be IL minus IC or IC minus IL depends on the value of IL and IC. Whichever is greater, that comes first, and the smaller is subtracted from the greater one. Now by comparing the value of IL and IC, it is quite clear that here IC is greater. So resultant will be in this direction. And that current is going to be now what? IC minus IL. Okay, fine. So here let us draw that now, the final phasor diagram. Here we have IR and the final phasor diagram is this, IC minus IL. Now in order to draw the resultant, I have to extend this and this becomes my final current. So how do I calculate this final current? Now from the phasor diagram it is quite clear that it is IR square plus what is this resultant? IC minus IL whole square. So what is the value of IR? It is 20 square. What is the value of IC? It is 40 minus 15 square. Correct? So it is 20 square plus 25 square. So that makes it 400 plus 625. Right? So square root of 1025. So the resultant current comes out to be 32.01 amperes. This is the answer. Clear? Yes. So we have drawn the phasor diagram also. Now let us go to the next question. Next question is a balanced three-phase star connected load consists of 3 coils. Okay. So it is a balanced load. It means star connected, right? So it is something like this. It is a balanced load. So we have a star connection and here we have ZPH. Right? So let us write the values now. R is given to be 6 ohms and XL is given as 8 ohms. Further, the voltage is given to be 400 voltage is specified to be 400 volts and frequency is given to be 50 hertz. Okay, so how do we specify the phase impedance? It is a series combination, so R plus JXL, which makes it 6 plus J8. Okay, now this is in rectangular form. I can convert this into polar form, so which makes it 10 and angle comes out to be 53.13 degrees. So what is the magnitude of ZPH? The magnitude of ZPH comes out to be 10 volts. And what is the phase angle? Phase angle is 53.13 degrees. Fine. Now how do we calculate the power factor? Power factor is cos phi. So it becomes cos 53.13. So power factor comes out to be 0.6. So this is one answer. Okay, now we have to find out line current. Now see, whatever voltage is specified in three-phase supply, that is always line voltage. Okay, now since it is a star connection, you have to remember, that line current is same as phase current, but line voltage is not same as phase voltage. So what is the relationship between phase voltage and line voltage? Phase voltage is VL by root 3. VL is specified, which is 400. So 400 by root 3. So the phase voltage comes out to be 230.94 volts. Now can I calculate the phase current? Yes, I can, because I have phase voltage and I have the phase impedance with me. So it is 230.94 and it was 10. So phase current comes out to be 23.094 amperes. Now as I said, in star connection, line voltage is same as line current is same as phase current. So even line current comes out to be 23.94 amperes. So this is our answer. Okay. So let us go to the next question. Now it says, briefly explain the classification of DC machine. Again, I would like to share that classification of DC machine is a part of self-study section and a detailed classification of DC machine is discussed there. Please refer to that lecture. Sixth question says, draw the phasor diagram of a single phase transformer when it is loaded with a lagging power factor. Again, we have discussed in detail the phasor diagram of transformer with a resistive load, with an inductive load which is lagging power factor, and with a leading load which is with a leading power factor which is a capacitive load. So we have discussed it in detail in the chapter transformer, which was chapter number 4. Fine. So let us go to the next question. Now question number 1 is complete. So it was for 20 marks. Fine. So let us see now what is our second question. Second question, again A part, it has been asked for 10 marks. Prove that the average power taken by the pure capacitor fed by a sinusoidal AC supply in a cycle is 0. Okay. So what it says is, you have a capacitor and it has been supplied with a sinusoidal AC signal. Fine. Now what do we know about capacitor? We know that current leads voltage by 90 degree, correct? Or which can be written as pi by 2. So if I write the voltage equation, what will be the voltage equation? It will be Vm sine omega t. So what will be the current equation? The current equation will be Im sine omega t plus pi by 2, right? Because it is leading. Now what is sine 90 plus theta? It is cos theta. It means that current will be represented by Im cos omega t. So this is equation 1 and this is equation 2. Fine. So let us calculate the instantaneous current, instantaneous power. So instantaneous power is the product of these two. So let us put these two values. So it will be Vm Im sin omega t multiplied by cos omega t. So sin A cos B. So that will be what? Sin A cos B will be half sin. It is actually sin A cos A. So it is half sin 2A. So it becomes 2 omega t. So this is instantaneous power. So this is equation number 3. Fine. So we have calculated the instantaneous power. Now let us go to average power. Fine. So for calculating average power, we have to integrate. So this is average power. So average power is taken over the area 2 pi. So 1 upon 2 pi. Then integration from 0 to 2 pi because we have to calculate it over a full cycle. And what we are integrating? The instantaneous power. Now with respect to omega t. So this is d omega t. Fine. So here we will be placing the value. So it is 1 upon 2 pi integration 0 to 2 pi. What was the instantaneous power? It was Vm Im by 2 sine twice omega t d omega t. Correct? Yes. So again we will be taking Vm Im by 2 outside the bracket. So it becomes Vm Im because these are constants. It becomes 4 pi integration 0 to 2 pi sine twice omega t d omega t. Vm Im upon 4 pi. Now what is the integration of sine theta? It is minus cos theta, but here it is not theta, it is twice omega t, right? So we have to differentiate it in the denominator, correct? So it will be minus cos 2 omega t by 2 with limit 0 to 2 pi. Correct? So further, let us solve this. So here it will be minus cos, I will take 2 outside the bracket. So it is twice omega t, right? So I have to place the value of omega t here. So it will be 2 pi, right? So it will be minus, again minus cos 0. So the value of this is 1. Again the value of this is 1. And this minus minus will become plus. So when I solve this, I will get Vm Im upon 8 pi minus 1 plus 1. They get cancelled. So what is the average power? Here it is 0 now. So anything multiplied by 0 is 0. So thereby we have proved that across a capacitor, the average power for a full cycle is 0. So with this, we are stopping today's lecture and we shall be meeting in the next lecture with few more questions of December 2018 question paper. Thank you.